Hi everyone. This video is for to show you how to use PSPICE to model a diet and see the output of a diet. So go to Cadence, Capture CIS Lite, click on it. This should come up. Okay. Then go to, so be careful. On top it should be OrCAD Capture Lite. You go to File, New, Project, and put a name for your first program, first diet sim, for example. Then press, this should be click, PSPICE analog or mix. By default, you're choosing this one. Then press OK. Create based upon an existing project. What it does, it just creates a ground for you. So press OK. So choose this one, OK. Okay, this is what comes out. And then you press on this, schematic, page 1, double click. And this is what you should see. So the ground, as I said, is already there, and by default it's 0, which is correct. Now I'm going to only add a resistor, which is here, and a diet. That's it. So in order to do that, go to Place, Part, click on Part. All the libraries you can use, all the components are inside these libraries. If you don't have the libraries, if you don't see anything there, press on Add Library, and then go to the PSPICE files and get the libraries that you need. So you are going to press on this, and it's pretty easy. Once you click on it, you will see, and you just add libraries, and it should all come here. Then you go on diet library. So as I said, all the libraries are here. So let's go to diet here. Let's go to diet. Then there are different kinds of diets, Schottky diets, Zener diets, they're all here. So what I want you to do is go to D. So as you see, there's a list of different diets. So choose for now D1N 4148. Okay, 4148, this one. And then double click on it, and it will come here, and then click. And if you want to get rid of this dangling diet, just press on escape on your keyboard, escape, so it disappeared. Then what you want now is a resistor, so you put R. Actually that will be in analog library, so you have to find analog library here, analog, click on it, and here's R, double click, put it here. So for now I want to, and then escape, and then in order to rotate it, right click, rotate. Okay, and then you need a source here. So for sources, you go to the library called source, which is before here, source, and I want sinusoidal voltage, so VC, double click, bring it here, attach it to your ground, and then escape. Okay, great. And then if you click on it and drag it, it will move. See? And it's connected. Then for wires, you can say place wire and then connect them together. So you connect your source to your diet, then you connect your diode to your resistor, and then you connect your resistor to the ground. You see this red circle? That's where you have to make sure they're connected, otherwise it wouldn't work. Okay, now escape. So this is my source. This is a sinusoidal voltage, so it will have a sinusoidal shape. I'm going to put V off, click on V off, put the value 0, press OK. I'm going to put an amplitude for my voltage source, so let's say, for example, 5. Okay. Frequency, let's put 50, for example. Okay. Okay, great. Now if you press run a SPICE, there is another window that you should see down, will come up. But for now, we don't see anything here. So that's the window. It's called a schematic. It should be, if you don't see it, it should be down there on the bar down. I'm pretty sure it's there. So then click on it and it will get maximized. Okay. So in order to see the actual sinusoidal, because this is a sinusoidal source, right? So you go to PSPICE, new simulation profile, put a name for it, for example, diode, create. This is where the setting for your simulation begins. Run to time, how long you want to see, for how long you want to see your signal. Let's put 1, and this is seconds, so 1 second. And press on skip initial transient bias point calculation. So the first part, I don't want to see it, and then press OK. Great. Now click on this voltage probe, connect one to your source, for example here, and connect the other one here after diode. Connect it here. And then press escape. And now run, see what happens. Okay. So as you see, the green one is my source voltage and the red one is clipped off because of the diode, because as you see, so this is a sinusoidal voltage. That means it goes this way, the current flow, and the current flow goes this way. But when it comes this way, it will get blocked. So you don't have any voltage drop here because it would be like an open switch. So when you don't have any voltage drop, the voltage for the negative would be 0. You see the red? The red corresponds to this probe, and the green corresponds to this probe. In order to see it better, because this goes to 1 second, let's see until 0.2 seconds. So you can go to PSPICE, edit simulation, make it 0.2 so you can see better. 0.2. Okay. Now run it again. You see? Beautiful. You see, this is your voltage source. And the red one is clipped off because of the diode. So you don't have any current flow for the negative part, only for the positive part. This is a rectifier. What I drew here is a rectifier because it's clipping off half of your signal.